back to the lecture series in cell culture technology. So, we are into the second week and we have finished 2 lectures. In the last lecture, we talked about or rather started talking about the layout and the design of the cell culture lab. So, while talking about it, I highlighted upon the first point is what is the objective of setting up the lab, what will be the kind of things or kind of experiments what will be conducted in that lab, and what is the next 5-year or 10 years plan down the road, how the lab will expand, what all new aspects which has to be added. Based on that, the layout design should be planned. So, in that aspect, we talked about the different kinds of lab, like whether you have a cell biology facility you wanted to develop, or a in vitro development biology facility if you want to develop, or you have a lab on cell based biosensors, cell tissue engineering like mostly on the material interaction with the cells, or chemical biology where you are screening different kind of drug molecules or fluorescent molecule, or some kind of biomarkers. Let me just add that part. Well, I have added all this, and or the biomarkers, or cell culture systems like medium development, substrate development, or the biomems where you have attempting to integrate the cellular or the living component with micro electromechanical systems. Okay. And based on that, the next part we went to figure out the objectives or the purpose, what we have already defined. We talked about the space constraints. So, what is the bare minimum space you have? We talked about the financial optimization, what level of sophistication one wish to achieve. Then we talked about the plan of expansion in next 10 years, which is basically you need a lot of far-sightedness about it, and the level of biological safety at which you are looking at. So, from here now we will talk about some of the precautionary measure what has to be taken even before you start thinking about the layout. So, realize one thing, say for example, you are designing a building, okay, which is far bigger facility and needs a different level of security. So, when you do so, there are a few points what has to be taken into mind. Say for example, it's a multi-story building or whatever, what will be the exit route, what are the safety measures one has to take into account, what are the possible hazards which may arise because of ill planning. So, whenever we talk about setting up a lab, especially of the cell culture, which is you are dealing with biologically active material and material which should remain confined within a space. The first and foremost thing is that you should have your entry and exit very clear. What I meant by that is that you should have a very clear cut entry into the system, and there should be an exit route where without any obstruction one should be able to rush out in case of any emergency. So, your entry exit should be very clear, very clear. It should be, the passage should be very clear. So, let me just put that down, like today we are into week 2, lecture 3, W2 L3. Precautions to be taken into account before designing the layout. The first thing should be your, before even if you put the layout, keep this in mind. So, these are the things which you have to keep in mind. Keep in mind. Okay. Your entry and exit should be very clearly defined and free from any obstruction. In case of any emergency evacuation. This is fairly critical. Now, second important thing. In cell culture lab, I have seen over the years, how much ever I can put all these things in writing, most of the time when people design them, they forget some of the basic things. Maximize floor area. I will explain what does that mean. Maximize floor area into visible to you. So, say for example, you have a facility. Say for example, you have a room. Let me put it down, that will make sense what I meant by this. Say for example, you have a room like this, fine. So, for example, this is your entry and a common exit. Now, you have options how you put the benches to work. So, for the working bench, over the years what I have realized and what always made sense for keeping the first point in mind, this point 1, and link it into the point 2, what you should do, you should utilize this part. The portion I am hatching or shading, so you see you have a huge amount of floor area which is, I am putting dots. This floor area is all available. So, the advantage with such an arrangement is, so you have other options. What you can do is some of the people does, which I personally, and I will leave it to your judgment how you will look at it. So, versus what people does, which is definitely not my choice, again facility where people will have tables like this to work, or like they will have a central table, or they may have something like this, one table like this, one table like this, like this one, this one, this one. There are several combination people does, but over the years after setting up multiple labs all over the world, I realized the easiest way is that you utilize this wall space. So, what you can do, you could have your working bench like this, and you have all the storage area on the walls. Okay. Of course, one has to be very careful when you set up the storage area, it should not be very high also, because at times that, or you could have make it high, but on the top shelves you can store all those stuff, which you will be needing later, okay, or you can have a complete storage area, right. So this is something which I will leave it up to, this is something which is my most preferred one, where you are utilizing this whole space. Now, all the cell culture labs across the world, they use something called CO2 incubator. Okay. We'll come later why you need, that is where you are needing the incubator for maintaining the pH inside the culture dish. So at this point, this is not important. Important is that to maintain a CO2 incubator, you need a supply of CO2 cylinder. And if you have these cylinders, and these are fairly tall cylinders, what you will be using. So you have to have a designated space, very, very designated space, where you should keep the cylinders, and that designated space should be preferably very close to the door, somewhere where I am putting the small boxes, or somewhere just outside. But if you, wherever you keep, remember one thing, this is one practice I am observing in several places where people forget that these are heavy cylinders. If they fall, they will hurt horribly bad. So you should have proper metallic clips to ensure the cylinder does not fall. This is absolute essential where you are keeping the cylinder. Ensure that that cylinder does not fall. Second thing, now the problem comes here. Say for example, you have a cylinder here, just try to imagine, you have a cylinder here, or you have a cylinder here, the places I am circling, and you have an incubator which is sitting here. Say for example, on this countertop, I am just putting in a blue, okay. Say for example, you have an incubator sitting here. So adjacent to the incubator, you needed to have a cylinder placing the cylinder. So you realize if you make the countertop in advance, so you make this whole countertop, then you place your incubator here, then you do not have any space, designated good spot to keep the cylinder. So even before you design the countertop, you ensure that you should have a location where the countertop become discontinuous, something like this. I am just kind of curving out in blue pen, something like this, either a space in the corner, and prefer to keep the incubator which will be holding all your cells, all your experimental material. Say for example, this is the incubator. Prefer to keep it as far away as possible from the main gate. And secondly, it should be in a corner where this should not be in direct contact with the air which is coming directly from outside, or whosoever is entering, there is always a air current which is coming. So try to keep it away from that air current zone, and as far as possible. So your option is that either you keep it here, or your other option is that you shift it here, where, but in both the cases, so these are the two shaded places I am designating for it. Now the thing is that whether you put in corner A, so let's D, and this is the entry E. Now whether you place it at A or whether you place it at D, now in that case, this countertop you are making, it will be discontinuous out here, and there should be enough space to keep the cylinder. Now you have to decide that how many incubator you will be buying, say for next 2 years or in next 10 years. Your lab may need only one incubator, your lab may need 2 incubators, you may need one CO2 incubator, another without CO2 incubator, just your incubator. These are important criteria to be taken into account well in advance. Now think of it, how much of a trivia these sounds, how much, because I know somebody will think, ah, what a big deal, this guy is talking things which, but the thing is that when you are planning a lab, you have to realize tomorrow you will be a leader and you are planning a lab and somebody will tell you, set up this facility. Your first thing you have to figure out that how many users are there. Say for example, okay, number of user. So there will be an N which will be coming out of it. Number of user. Number of user, say 2017, and you are planning it, down the line, like, this should be one of the best facilities. So you have to have a margin to tell that how many user will be there in prime by say 2027, because you are not going to make a facility like that, right? And this user N varies. Are you making a departmental facility, or you are making an institute facility, or you are making a individual facility? If it is an individual facility, you should know how many, say, undergraduate, postgraduate students you'll be having, or a postdoc you'll be having. If you are making it a departmental facility, you should have a rough number of how many faculties you'll have and their corresponding numbers of users. Say for example, there are 10 faculties and each lab has like 2 or 3 designated people to use it. So while talking about designated people, this is again something which is over the years of experience of almost now 2 decades I have learned. It is always a good idea for such specialized facilities to have designated people. Like, these are the designated people who will be using or who will be will be ensuring it. Too many users in these kind of facilities leads to a lot of contamination problems. It is not always a very good idea that everybody gets in and gets out, unless otherwise this is your absolute private facility. This is your own facility and you are the boss. But when it comes to departmental and institute, then it is better to restrict. Every lab should have some restricted numbers, which has its own drawbacks though. But one can always at one point, this month you have these designated people, the other, like something of that sort has to be. It's maybe a wise idea, but if you can really manage the trained individual, you can train them right, no problem. So I will leave it up to the user. Okay, how many designated users? So by say 2017 to 2027, next 10 years, how many users will be there? Based on that, you have to assign out here in these incubators who will be using how many shells, because these are costly affair. When you are getting an CO2 incubator, it costs a fortune. Okay, for a new PI or a new faculty who is starting, it's always a challenge. So you should have a very clear idea, like these shelves are designated. But then again on top of that comes who will be using what kind of stuff. Say for example, somebody is growing cells directly from animals, what we call as primary culture, which are much more prone to contamination, because it's kind of a you need very well trained personnel to take care of it. Whereas somebody using a cell line, which is less prone because the cells are safely kept in a nitrogen cylinder. And so how you are going to classify it? Or you will have like, suppose there are 4 designated users, each user has their own incubator, or mini incubators, all of them. You are free from it, it's your incubator. But then if you have the incubator, then the gas management also should go in hand in hand. I have seen over the years in common facilities, you have a gas facility and people who are using it forget to figure out that gas is depleted and the cells die. These are very common day-to-day problem, and trust me, this happens and it leads to catastrophe. So first and foremost, you should know how many users you have and how you are going to divide it out. And again, I am just putting some word of caution. It's up to you people who will be the user, they decide. So I will not overemphasize, but again I will do an optimal emphasization on that please be careful. So now next thing comes, Most of the labs who uses cell lines, they needed a facility to store cells in cryo cans, where you have to have liquid nitrogen ports. So, these cans are very interesting. These are cans like this. Let me draw it for you, that will make more sense. Those who have seen milk cans, it is almost similar to that. It's just a little bit more circular, and there are lot of holders to keep cells inside them. These are like cell holders. I am unable to really draw it the right way, and there is a cap on top, and you pour nitrogen into it, and in these you have holders something like this, very nice holder. In these kind of holders you have these vials, small vials, you kind of stack those vials on this like this, something like this, okay, and you take this whole thing and keep it inside. So, these are every cell culture lab who are maintaining cell lines, they maintain in it and they remain in liquid nitrogen temperature, and they can remain years after years, decades after decades in them. But the only thing is that you have to ensure you have liquid nitrogen being supplied time to time to replenish for it, and every time you are opening it, there is a depletion of the liquid nitrogen. So, you have to replace it over a period of time or every week or likewise. So, you have to understand where you want to keep them, because these are heavy stuff. Okay. So, coming back to the design, so you have to have a designated spot either under somewhere, somewhere you have to have a designated spot where you think that this is the best spot, I can keep it here, because every time you have to pull this out of the lab, or you have to bring the nitrogen can and fill it. So, you ensure you do not want to travel all the way out here. But that brings us to another problem. Whenever you have an incubator in this corner, you always have to have the the carbon dioxide cylinder to be taken all the way up to here. So, whenever you do it, please ensure this has happened, that you do not spoil the whole floor, and ensure that underneath that nitrogen cylinder, carbon dioxide cylinder what you are carrying, CO2 cylinder, you ensure that at least it is clean enough. It should not cause unnecessary mess around, because most of these cylinders when they come. So, wherever you store them, ensure as soon as the cylinder arrives from the facility, you clean them up, at least mop them down properly. It is heavy, so you have to be careful, stack them properly, and whenever you need to take them, just spray them a little bit with an alcohol and clean them, and just take them from the side, and prefer to follow like this, okay, instead of going through the center. It is not a good idea, because it spoils the floor. Okay. So, now after that I have talked to you about where to keep the nitrogen can, or these are the cell line storage cans, and ensuring regular supply of liquid nitrogen to replenish the consumed liquid into. Okay. So, you have to have a designated spot for it. So, essentially you have to have at least one can, one of these vessels, and another one to bring the liquid nitrogen to fill this. So, you need to have at least two if you are maintaining a cell line, minimum two, and if you design it right in the beginning, then you will be doing better. And This kind of vessels have different sizes, and I have seen several labs have several kind of sizes. One thing I realize, you have to have really, first of all, you have to realize how much quantity of cells you wanted to store, some prediction, something. And second important part about this is that if you take a very big one, then its movement will be an issue, will be always an issue. If you take a very small one, automatically you have a how much quantity you are, storage will be a big issue. So somewhere in between, you have to draw a line, what will be the size of it, which is easy to, its maneuverability, movability should not be a challenge, and yet you can, get your things done. So that's very important that you understand this part. Again, this all comes in the planning game. Now coming back to the design area, so I told you that you have one corner, you have the CO2 cylinder as well as the CO2 incubator. These are the critical thing which has to be maintained there. Then you have to have the devour, keeping the cells somewhere stored. Then we talked about storage of the cylinder at a specific location, where the cylinders has to be ensured that those cylinders are properly hooked with chains or clamps so that they do not fall down. Another important thing, whenever I talk about cylinder, this is something I have experienced and it has pained me time and again. Always, always, always buy a trolley to transport the cylinders. I have seen graduate students rolling the cylinder, moving them like this. It's a very dangerous practice. Please, how much soever boring I sounds, these are the goddamn problems. Please, when you design a layout facility, buy a small trolley with hooks. There are things, or you can attach a hook from your workshop so that it ensures the safety of yourself, your fellow colleagues, and everybody around. Please, please, please ensure that, because this is something which is drastically missing, and you should have a designated spot for that trolley, that no one should take it from some other purpose. So whenever you need it, you should have the trolley with you. You take the trolley, bring the cylinder, and you may need, there is one more small trolley you may need, which is slightly of different kind, to transport these kind of, if you are really buying a big one. The small ones you can really carry in your hand like a bucket, but big ones are always a problem. Okay? So these are some of the very beginning. So we will continue in this line what all other things. So in that process, from layout to all the basic requirements will be, completing in that process. Okay? Thank you.